Welcome, hello. This is Matthew Wynn. I'm master of John J. Lodge number 653. We normally meet in White Plains, New York. This is our stated meeting for April 2021. I have a short presentation on the 47th problem of Euclid, also known as the Pythagorean theorem. Let me start that screen share because I've got a PowerPoint. I did this design of the 47th problem in my own CAD system that I work on at work, which should enable you to think that, yes, I'm a geometry nerd. So this is why the Pythagorean theorem and the 47th problem of Euclid is really so interesting to me. Some of you may remember the Pythagorean theorem from grade school math. I thought it was high school math, but my kid reminded me, no, this was like sixth grade stuff. And this is the famous a squared plus b squared equals c squared. This only applies on right triangles. That's a triangle with 90-degree corner over here, where the right angle triangle, the sum of the squares of the hypotenuse is equal to the sum of the squares of the other two sides. And I would say that this is teenagers' nemesis because everybody is wondering why this may be the first time that people have seen some squares and stuff like this, but let me just tell you, this simple thing can be used to measure everything in the world, from the size of your bottle cap to how far we are from other stars. And even in The Wizard of Oz, the Scarecrow recited it after he's got his diploma, but he actually got it wrong. Let me see if I can bring that up real quick. He actually was slightly incorrect. No, that's bad. So Scarecrow was so happy that he got that right out of his brain, except he was talking about an isosceles triangle, and this is a right triangle. So shows you that it really helps if you do have a degree. So all the kids say, where am I ever going to use this? They pull that just like they said about everything in math, right? Well, I am a geometry nerd and I use this in work. In 2 dimensions in X and Y, you can use it to find the distance between 2 points, like point A and point B is approximately 4.77 here. In 3 dimensions, you do the same thing in X, Y, and Z. So it's the square of X plus the square of Y plus the square of Z is the square of the distance between the 2 points. So that's what keeps me awake at night. So why do we have both Pythagoras as the Pythagorean theorem and Euclid as his 47th problem involved in this Masonic thing? Now, Pythagoras was an adept of all these mystery schools, and he had all these math and scientific discoveries. He even had a mystery school of his own, which students that had a vow of silence that they wouldn't reveal secrets. Sounds familiar, but there's a lot to talk about Pythagoras. His wiki page is very long. Wikipedia page is very long, but what it said that when he discovered this theorem of the square of the sides equals the square of the hypotenuse, that he exclaimed, Eureka, which means I found it, and he sacrificed a hecatomb. Anybody here know what a hecatomb is? It's a bunch of oxen, like 100 oxen, maybe only 12, but anyway, sacrifice a bunch of oxen. But so he was the guy that thought of all of this stuff. Why is Euclid in here? Now Euclid, his Wikipedia page is a lot smaller, but he's famous for writing some books. Although some people doubt that maybe he was the actual writer of those books, maybe somebody else wrote the books, because apparently the oldest copy of Euclid's Elements that is in the Vatican doesn't even have a byline on it for Euclid. It's just called Elements. But Euclid's Elements was the primary textbook on math and geometry until like very recently. He had the proofs that included it with this unique 3-4-5 triangle, which is what's in the 47th problem of Euclid that the Masons used. It took me until I was in engineering school to see that the coolness of 3, 4, 5 made the right triangle. It was kind of like, I almost had a eureka moment as myself when I saw that and thought, wow, that's so cool. But these ideas were known long before Pythagoras. The Egyptians and the Babylonians and the people in the Far East, they all knew about this relationship long before that. They've even got these tablet from Babylonia that's got those Pythagorean triples written down on it in cuneiform. And here's some of those other Pythagorean triples. These are all other numbers, 5, 12, and 13, 7, 24, and 25. Those are also numbers that have that relationship being the sum of the squares of the first two is the square root of the third. So the easiest thing to prove this is a simple, let me show you some geometry. And if you look at this C2 triangle, it's got to be the same size as this A squared and B squared, A2. So that big triangle has got to be the same size as the sum of the other two, because we're just moving two triangles inside the square. In the 3, 4, 5 triangle, we've got this 3 squared and 4 squared and 5 squared. Everybody can see that 9 plus 16 equals 25. Now there's lots of different proofs to this. I still haven't looked up any of those. But one was written by US President and Masonic brother James Garfield. That's one that I should try to look up. It's hard to actually dig out these proofs from what I've been seeing. So everybody claims that this 3, 4, 5 triangle is used in architecture and building, and to lay out the corner of foundations, people made a rope with knots on it or a chain or sticks to make this 3, 4, 5 triangle. And they say that in ancient Egypt, the people making the pyramids and all the other square buildings with the square edges use this triangle to lay out the square edges of their buildings. And we know the pyramids are precisely north and south and east and west, and they're square. But there's a math historian named Roger Cook who says there's easier ways to create a right triangle, such as make a half triangle with a line through it, and then any triangle inscribed in that is a right angle. And you can make one of those with a compass and a rule. You don't need ropes and chains. And I always think about this as, you're going to make a rope that's divided into 12 sections. If I was tying a knot in a rope, I can never tie a knot in the exact right place. And here you're asking somebody to make a rope with a knot tied at 12 precisely separated places on their rope. So that's why I think that would be hard to do. But this was the claim, that they used the 3, 4, 5 triangle to make a right angle to build all these buildings. The interesting thing about early Freemasonry, and one of the reasons I was so excited about it, is that there are a lot of references that actually say masonry or geometry, like masonry is geometry. And depending on how far you want to go back, it says it even more. Anderson's Constitution, one version of it has the 47th problem of Euclid on the frontispiece. And in there, it describes, in Anderson's Constitutions, it says, if duly observed, the 47th problem of Euclid is the foundation of all masonry, sacred, civil, and military. In Duncan's third degree lecture, it mentions it in only 4 brief sentences, but it concludes with, it teaches Masons to be general lovers of the arts and sciences. And most Masons, I think, just leave it as that. This is a little image that teaches us to be lovers of arts and sciences. Now, this picture here on the right is a picture out of Duncan's third lecture. The weird thing is, if you look closely at it, that's not a 3, 4, 5 triangle. That's kind of an equilateral triangle in the middle there. The other thing to remember about Pythagoras and its influence on early Freemasonry is that there was the revival of Pythagorean philosophy during the late 1600s, which is when Freemasonry was emerging out of the Enlightenment period. Modern day Freemasonry, the symbol of the 47th problem of Euclid is used as the past master's jewel in many jurisdictions, including United Garage Lodge of England and Pennsylvania, but not in New York. Too bad for me, because I like this picture so much. I got one on my lapel though. Anybody can get one of those. Just don't wear it in Pennsylvania unless you're past master. Now we get deeper. What other symbolisms can you pull out of this 3-4-5 right triangle? Some of you have probably remembered that 3-5-7 is an important set of numbers in Freemasonry. Where do we get 3-5-7? If we take the square of the first four numbers, 1, 4, 9, and 16 is the square of 1, 2, 3, and 4. If we subtract each square from the next one, we get this 3, 5, and 7 from subtracting the squares. These are the steps in Masonry. They're the steps in the winding chair. They're also the number of master masons necessary to open a lodge. 3 to open a master mason lodge, 5 fellow crafts, and 7 to open an entered apprentice lodge. There's so many other symbolisms that were written up in some of the stuff I read. 3, well, we discussed the significance of the number 3 at our 333rd communication a while back. I hope we can remember some of those. If you've seen the recent BMW car commercial with all the 3 cars, they admit that in some locations, 3 invokes deity. Here's one that I hadn't thought about. The famous Masonic scholar Mackey says that a lodge should be 1/3 longer than it is wide, so that the sides would be of length 3 and 4. That would give it a diagonal of 5. And don't even get me started with numerology and numerical reductions and Kabbalistic numerology, who takes these numbers and reduces them to the single numbers. And you go into that, you can even relate that Noah is the mirror of, Moses is the mirror of God, and in the numbers. We can read that up in this Burkle thing. Burkle went pretty deep in some different number things. So one reason I wanted to delve into this so far is because not only did we see the 3 squares, is you see this picture sometimes on Masonic documents. And as the geometry nerd, I'm like, what do those lines and points and arrows means? There's no arrows there, but what do all those lines mean? Well, let me tell you, I still haven't figured that out. So I still have some work to do to figure out exactly what those mean. I think that's from the actual proof. Geometric proofs are kind of hard to read, but when I find it out, I'll let you guys know. Have you guys ever heard of magic squares? Here's something really cool. A magic square is a square with numbers in it, such that the numbers in the rows and columns and diagonals all add up to the same number. And this has been used in magic and a lot of other things, and just some people just don't have a life and they really like magic squares. Last time I saw a magic square used was in a magic act. I had to give somebody a number, and then they tried to write down the number on a square of 4 numbers. And of course, they didn't have my number written down there, but they had a magic square for my number. And everybody went, ooh, anyway. I knew what magic squares were at least. But this is a really cool magic square where we've got 3 magic squares, and the row and column and diagonal of each of them is 174. And these are the sums of the numbers within the squares. So they all have the same magic number. But then if you take the sums of these and those, they are a Pythagorean triple. And if we do that same diagonal, that's 174. And here's that numerical reduction I was talking about again. That turns into 1 + 7 + 4 = 12. That reduces to 1 + 2. That reduces this to this secret number 3. So that was pretty cool, if you're into that kind of thing. Well, my conclusions on this short talk, like most Masonic symbols, we've got a practical use, an explanation for the 47th problem. One thing that I realized is, I'm not that young, but even when I was brought up, we didn't have much classical teaching. All this stuff about Pythagorean and Euclid and that classical teachings of antiquity, even I didn't get that back in the 70s. But they do have practical and philosophical applications today. And I think, in fact, one of our brother's childs just did a minor in classics. So maybe I should talk with them about it. Anyway, the big thing though is, like many Masonic symbols, there's lots of levels of symbolism in the 47th problem of Euclid. And I still have more to find out myself. And I hope this interests you to maybe ask some questions. And like any good report, I've got these references. My friend Aram had a nice lodge presentations. And there. So any questions or comments from anybody here? Thank you for your patience.
I'd like to make an observation, Worshipful Master. You mentioned earlier that in Pennsylvania, in the United Grand Lodge of England, the past master's jewel is a 3-4-5 triangle, right?
Yes, suspended from a right triangle.
But not in other grand jurisdictions necessarily.
Yes.
I suggest that may be due to the fact that when they had this split in the Grand Lodge of England, some of them were Athol lodges, and the Athol, the RR New York, it came out of the Athol lodges. Later, when they merged them, they went back to the ancient.
I would agree that is exactly the reason why.
Yeah, and Pennsylvania is descended from the ancient side. Well, we're from the Athol.
Pennsylvania has a lot of differences. I would love to go attend a lodge in Pennsylvania. Ramon, it's good to see you. Thanks for joining. Yeah, there you are. Any other discussion on the 47th problem or Pythagoras himself or anything like this?
One commentary, please. Worshipful Master. Thank you. It was a beautiful presentation. Only one suggestion is there is a beautiful application of the geometry in the design of the apron. The Mason apron has a specific characteristic in the geometry, copy of the extension of the line that the Cancer tropic and Capricorn tropic, they are two lines in parallel, give the extension and cross the lines and get the design of the Mason apron. That symbolism is a perfect application of the geometry copy of the cosmogonic geometry. That kind of symbolism is copied too for Gmail corporation or Gmail. If you see the symbolism of the Gmail, you will see the apron. This is the apron of the Masons. They copy that symbolism. This is only one suggestion, Worshipful Master. Thank you so much and beautiful presentation. Thank you.
No, you're absolutely right. The Gmail logo for a long time was almost exactly like a Royal Arch apron with the red borders. Although in the past few months or year, they've changed it so it looks a lot less like it. But it does look an awful lot like a Mason's apron with the triangular flap.
Very good presentation.
Thank you, Robert.
Worshipful Master.
Yes, Ramon.
Another number that I kind of been keeping track of recently, because I ended up watching actually a special presentation on it, was about the number 12 and basically showing up almost everywhere, whether it be on with science, geometry, the zodiacs, the calendar, counting by counting right here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. and how it's divisible by itself. So like that's another number that I've actually kind of been keeping track of. I never realized that one.
And how would you count to 12 on your hand?
So like if you go like this on your fingers, you have like the little 3 squares, 1, 2, 3, 4,
Okay.
5, 6, 7, 8, 9, 10, 11, 12. This wasn't actually used to count. This was actually the pointer.
So touching the different joints in your finger.
Yeah.
Okay.
So it made it easier to count, and it was an easier number to work with.
One thing that gets me about numerology and astronomy and that stuff is it depends on some kind of random things that we developed here on Earth. Namely, that things are our particular calendar, which seems kind of random. And the fact that we have 10 fingers, which is why we mostly count in base 10. All of numerology reducing numbers to a single number assumes that we're in base 10. And what if we only had 8 fingers? Would these numbers still be as significant?
No,
Exactly. That's what I think. So there's some interesting things in numerology, but I think there's also some limits if you can count in bases besides 10. Last chance for a comment. Jay,
So, Worshipful Master, when I was in college, speaking of uses of the Pythagorean theorem, when I was in college and in Buffalo and had
oh,
no
I was there
tools,
too.
yeah, I know you were, but at a different time and a different dorm.
That's
I-
why I said Eureka.
Yes, I had no tools whatsoever to my name at that time, other than a lug wrench and a screwdriver from my car. However, I was able to use the Pythagorean theorem to sketch out and plan out a loft bed for myself, go to a lumber yard, have them cut everything to spec and drill the holes for me. And I just used lag bolts with wing nuts on them. And I was able to assemble an entire loft bed that was strong enough to carry my weight and the weight of any lovely young lady that might accompany me for the evening on that bed.
Can you describe how you did this briefly?
Sure.
You laid them end to end and counted 3 and 4?
I sketched out or measured out the size of a mattress. Then I had to have I had to select the height for the legs to support it. And then I had to figure out the braces. The braces is where I use the Pythagorean theorem
Sure.
primarily. So I had to put braces all around it because I'm not a light guy and I didn't want to fall through a bed that I was making. So that's what I did. So using 2x4s, 2x6s, and 4x4s, I built and a piece of plywood, I built myself a bed.
The great things that we learn in college.
Yes. And I learned all that, how to do all that in probably junior high school or high school.
Anybody have any other suggestions on the topic? What would you like to hear next month? Actually, in 2 months. I'm gonna stop the recording.